Wherever you are, welcome to episode 80-something. I'm unclear what episode we're on because there's so much awesome happening here on the Cloudcast. We are coming to you live from the CloudConnect out here in Santa Clara. So with me today, by the way, I'm not Brian Gracely. I'm not Aaron Dell. Once more, this is Amy Lewis at Comms Ninja on the Twitters, host of Engineers Unplugged, and apparently hostily taking over the Cloudcast.net podcast. So I'm here with Lew Tucker and Dave McCrory, and they're having a great conversation about data gravity and how the network is changing, what the impact is on cloud computing, and we're going to get to listen in. So, Lew, Dave, introduce yourselves. I'm going to let you guys take it away.
Dave?
Sure. So I'm Dave McCrory. I'm SVP of Engineering for Warner Music Group, and I'm also the coiner of the term data gravity.
And I'm Lew Tucker, VP and CTO Cloud Computing at Cisco Systems. I just finished the talk trying to tie a lot of these things together between cloud computing, big data, analytics, software-defined networking. So I think if we just would kind of continue where we were going with it, because data gravity is a term I've also used, so I borrowed that from Dave. And why don't you describe maybe what that is first?
Sure. So the idea or the concept of data gravity is around data accumulating over time by being used by applications and services, and when it's used by applications and services, it is using them over a network, and the applications and services are advantaged by being closer to the data because it's lower latency, which means they can get to the data faster, and generally it means higher bandwidth, which means they can get more of the data at a time. Those benefits have an attractive effect for the applications that want to consume the data. As the applications consume the data, they generally create more data. And over time, as that massive data increases, it attracts even more applications that are also competing to try and get closer to that data.
So this is all about moving apps to the data. But right. But I mean, we were saying there's some limits to that too, because the apps actually are not connected to a single piece of data. They're actually increasingly connected to a large number of things across the network.
That's right. They're becoming a complex system.
So we get back into the entropy discussion then
That's
about
right.
how we were talking earlier actually about how we can relate this to a lot of things in biology and relate it to things in physics, and gravity emerges actually out of these things. So that's part of your whole thesis, right?
That's right, and something that I'm seeing is our incidents of people deciding to try and transfer data to an application, and it will be 4 weeks of data transfer so that they can run a bit of logic for 15 minutes. And it's kind of amazing that you would expend all of that effort transferring 4 petabytes of data so that you can run a 15-minute operation on it, instead of simply moving the application logic to the data.
Right.
Both are viable, but one is going to take a lot longer.
Yeah. But also, if we look at things like Hadoop and Hadoop, HDFS, and everything else, we're finding that we want the data to be close to the application. The applications are distributed, and now the data is distributed. So we don't necessarily mean by this notion of data gravity that all the data is going to be consolidated into a single point of singularity.
One big machine.
We're really talking about just data, the executable content. Actually, back in the early Java days, we were talking about executable content, meaning that what you're transmitting, and even like on a DVD, was an application, not just the end result of the data, the video stream, but actually an app that actually could now show you either the author's cut or the condensed version, or tell the app I've only got 45 minutes and I'd like to see this movie or something. So applications are being tied to data, and that I think is something that we're seeing over and over again.
I think in a lot of many traditional IT systems, we're seeing that the application and the data were assumed to be so tightly coupled that they became one kind of mass or one thing, and that actually caused a lot of problems, which is what drove us more towards trying to move things to using RESTful interfaces and all these other things. The real cloud scale providers, the Amazons and the Netflix and the pick your poison, Azure, any of these, if you're trying to use their platforms, they actually encourage to use stateless style of applications. And that's what stateless means, is that I'm not going to store information about each individual user up in the sky somewhere. I'm going to store it locally on the device they're using. So think of cookies in your browser as the ability to store state locally instead.
But that means that other concepts, pushing things out into the edge.
That's right.
And this is where we want computation to be pushed out to the edge, and we want data to be pushed out to the edge. Because as we were talking before, if we were to collapse everything into this hardened little silo or whatever, that's a huge point of failure.
That's right.
And instead, all the resilient systems we see with Netflix and everything else are based upon distributing out the application as far as you can, components of which can be stateless, but also any part of the application actually can fail, because we know that large-scale systems fail, with the rest of the application. So resiliency, I think, is the other component of this.
I agree and that's one of the benefits of following these patterns, this stateless, idempotent style of design. And the same thing applies with virtual machines. So one of the benefits classically of things like vMotion has been that you would be able to maintain that state as you move it across the network, and you wouldn't get network drops and things. That was the miracle of vMotion at the time. What we're seeing is, at least what I see, is that more often than not, if new applications are being written, they're being written with different expectations than previous. A lot of applications, the expectation was that the system would never go down, ever. What I was running on would always be there, and I would always have fast access to the information. Those were the assumptions from the beginning. That's true with most enterprise IT applications. But if you look at what has been done by the cloud pioneers, the Facebooks, the Twitters and such, they don't have those same expectations built into the actual application. They may or may not use virtual machines, but the application doesn't expect instantaneous response time. It's not synchronous. It's asynchronous. That's something else. But again, that relies and that expects that it's going to be across a network. It's not going to be that singularity thing.
I also can relate it to a lot of what the work that's being done that we're doing, like an OpenStack, and in terms of defining a network service. Instead of the network being this thing just in the background that somehow miraculously is able to push around their packets and everything else like that, where we know there are very hot links at different points in time that doesn't know how to necessarily respond to changes in the application load, the amount of data. Instead, we're looking at we want to actually have the same programmable interfaces and even RESTful interfaces into the infrastructure, so that you can start doing things such as load balancing as a service, firewall as a service, build them on the same model that we're seeing that's successful in the cloud. These are large, distributed, dynamically scalable, elastic systems. That's a much better world, because it increases simultaneously the resiliency, better utilization of the service of the underlying resources, and at the end contributes to a better user experience of these applications.
Are you seeing, it's very interesting as you talk through some of these examples, are you seeing both the successes and failures that are happening in the B2C world of cloud being brought back into the conversations you're having around enterprise?
Yeah. I've always maintained there's fundamentally, we're two different kind of software architectures that we've been pursuing. One has been sort of enterprise IT, vertically built applications designed to run on hardened systems and everything else like that, and they serve a small number of employees, your financial services or just your, some part of your organization. The web architectures have always been built largely on open source, large-scale distributed systems, stateless front ends, being able to design horizontally. And that's the battle that's going on. And I think that it's clear who's winning. Right now, I think it's these large-scale distributed apps who are showing they can outperform, in terms of their resiliency, these attempts to harden something that we've seen in the enterprise. And more of IT, I think actually, give a plug for Jeffrey Moore has this wonderful analogy between systems of record and systems of engagement. Systems of record, he says, we actually solved all those problems with the year 2000, bug or whatever. Those systems are sort of done. They're only going to grow as fast as the industry. With systems of engagement, which have to do with how are we interacting with our supply chain, our network of suppliers, our customers, our consumers, those are growing out of the middle of the organization. And they need IT systems to be able to do that as well. And then it becomes tied back to the whole data gravity. Well, maybe most of your data is now going to be outside of your organization. It's going to be on your consumers' cookies. It's going to be in these other systems and your suppliers and vendors. And IT now has an opportunity, I think, to start to view things from that world so they can run big data and they can do all these kinds of analysis to better understand their customers and their supply chains and their systems of operation as well.
It's interesting, I think, when we talk about big data, I think one of the problems is that right now people think that big data is the universal answer to everything and that they're going to simply be able to save their data in what's a data warehouse in their concept forever, and that magically they can send a query to this thing and they can get the answer to any question they have. And sadly, I think there are going to be a lot of failures in big data projects because of that. And then I think once that happens, we'll see a maturity in the big data market, and they will start to they'll start to realize that there's a difference between data and information, and that information
a big difference.
Is where you can take action.
Do you see the challenge there as a part of the warehousing problem and the fear of failure? And think about people's implementations for some of these solutions. Do you see that as a fear of failure in the warehouse or a fear of latency and failure in the querying layer?
I think it's a failure of access. I mean, that what you're trying to do is make all parts of the business be able to essentially explore the data that's behind their business. And therefore, making it so it's streaming analytics if you need to respond in real time. It's this much more rapid turnaround between data exploration. Make an ad hoc query because somebody would like to know how many of my customers, are doing something at the same time. Next to the milk aisle, what should the most likely product be placed or whatever, and reduce that cost instead of being some trouble ticket that's filed with an IT organization that has to go through a review process and everything else. No, you want to just answer that query. And because we see that, we can do that with Google today. I can ask these kinds of exploration questions.
It's kind of a data exploration with the goal of information discovery, where you discover this new bit of information that you're then able to apply and take some type of action or change some part of your business to now do something differently based on that information you've discovered by going through the data. But it's not just about the data.
And Dave, I love your point. I know we've talked about it before. It was a part of your keynote in saying, don't confuse data and information, the concept of information technology, and that data without context is not as fruitful, and the more distance you put between it, the harder it is to get business intelligence out of it.
Well, that's right. And if you think about it, if you lose the context around the data, if you even think about a classic relational database, if you had no table definition and you just had a data dump, purely just the data that was stored in that database in some big file, and you had no context whatsoever, you would either manually have to go through the information and try and classify it yourself or do something else.
Or use a shell script, which is grep followed by sed, followed by something else to try to...
And hopefully you can piece things back together, but it's you just have a lump of data. And that's what a lot of businesses are doing right now. They're just creating these big, huge mountains of data, but where are the things to tie it together? And
it's like digital hoarders. I keep thinking,
exactly.
Why is there not...
I think that's a great analogy. I feel like every time I buy another terabyte disk or whatever, just because I need it,
Well, and it's fascinating, for folks to think about the macro, micro here, some of the old practices in terms of relational databases that you would use to do web dev, back in the day. Everything old is
the worst
new
thing
again,
about it. I mean, so there certainly is a role, and SQL actually there are languages we want to use to express relationships in data, but that doesn't necessarily mean how we want to implement it. Mm-hmm. And so there's a lot of projects around changing that. The problem has always been if you set up a schema, you can only ask a certain class of questions about it. And what we're seeing with all of this unstructured data, and you want to do data exploration, now that's different. So you may behind the scenes go through, different extraction processes to sort of get the kind of data, views or slices out of this information. At the end of the day, you have to be able to respond to somebody who wants to ask a question, and that's where it comes into information. It's not just data at that point.
Which is why I think we have so many new classes of ways to store data. It's not purely about being able to have eventually consistent data or transactional versus eventual. It's more of, a while back when I was doing a lot of research on semantic databases, and we had these ideas. That's right, RDF tuple stores.
Yeah, I did that for a couple of years.
And it's very much, it was very much this idea.
That was the Web 3.0. I'm afraid we're still waiting
for
that.
Yeah, that's right.
This is the year, right?
Yeah. But it's ironic that we do have new ways of storing information outside of relational databases. We have key value stores and all sorts of other things. Some of the newer things that we're seeing are social media pioneers, Google and Facebook and Twitter, are graphs. They're applying graphs. And for the listeners that don't know what a graph database is, think of drawing a circle, a line connecting to another circle. That's conceptually what a graph database is doing. It's taking a circle with one bit of information. It's creating a link to another bit of information. It's describing all three pieces: the first circle, the link itself, and the other circle. I'm simplifying.
And there are languages, Sparkle, and some others that allow us to express or to ask questions of that graph. How many of my friends are within driving distance of a place where I want to have a party? Or something.
And that's what the Facebook graph is really doing, is allowing you to traverse a social graph like that. That's where all of these graph terms come from. That's how LinkedIn says you have so many connections in your social graph, and it's why you have secondary and tertiary. All of that is based on graph technology. That, in my mind, gets us one tiny thin slice step closer to having information with the data and being able to ask really interesting questions that weren't originally planned for when the system was implemented. And that's the problem with what I call legacy apps, which is really all the apps that all of us have today, everything. It always had a specific purpose, and anytime you moved outside of that, things fell apart, or you couldn't ask your questions anymore. Businesses want to ask all sorts of new questions on a daily basis, but they have no way to do it.
And we're seeing more and more data being made available. So one of the great things, I think, is this kind of open source data. I mean, we're opening up data sets for people to play with, create these applications around. I was talking about this morning about in San Francisco. The city is now instrumenting the parking spots. So you can actually now, there's an app that when I'm driving in San Francisco, I can find out, the closest open parking meter. Instead of now, it saves the city a lot of money. It cuts down on pollution and carbon emissions and everything else like that. And not only did they make the app available and do all the sensor, instrumentation and everything else, but they make the data set available. So that means now anybody else can develop an app that uses that. So it might be somebody who's trying to do route planning for delivery systems, or they want to be able to say, where should I open up a restaurant? Well, where are the least amount of parking spots at any given time? There's a lot of other uses of that data. So back to this notion of a graph, I think where things are going to end up, because of data gravity, you want to be close to the data. If the question you're asking involves lots of different data sets, now you maybe have to have agents that essentially go out, and this computer science talked about this for a while, send out the agents which will go be close to the data, answer it on your behalf, and bring back then the information instead of the data.
Yeah. Wow. I mean, that's, and it's so interesting that you're both giving these very real-world practical examples.
Well, we've probably read the same science fiction writers, and they explained this all many years ago.
That's right.
We just should have done. Literature is obviously, it's been a theme this week.
In the metaverse all along.
So as you have these conversations internally and externally with customers, how are you bringing some of these practical applications to bear? I mean, again, I love these kind of very personalized examples, because I think that makes this very conceptual thing practical for people. What kinds of
let me give you another example. So a large company in the agricultural space, which is planting seeds, and combines, in fact, are collecting information every time they go down the field. Engaging, I had a conversation with the CEO of that company or whatever, going, what are you doing with the data? Oh, it's so hard to get. We can't get the farmers. They have to put in a USB key and then go to their granddaughter's computer, whatever, try and upload. I'm going, well, that can be solved. Just put in wireless sensors and everything else like that on your combine. Oh yeah, but then nobody really wants the data. And I said, well, if you could have the data, would you have an opportunity there? He said, oh yeah, it would be great. We could tell them exactly what time to plant. We could tell them exactly what seeds to use and everything else like that. But we're not in the application business. I'm going, well, you're in an ecosystem. But no one's building those apps. And I pulled out my iPhone. I hadn't done this before. Typed in like agricultural stuff, and sure enough, there are like 35 apps available today on an iPhone that was a shock to him to say, here's how a business opportunity directly suited to what that guy can do. You have to start thinking in this way, and then there's plenty of opportunity.
And it's interesting. The thing I'm also noticing is that one of the advantages of working this new flexible way is that you are able to leave room for questions that are yet unasked, that you are creating opportunity, and that concept of if you don't harden the data so much that you, with a presupposed set of questions, then you're able to ask questions and react. I would say I can see that the risk factor there too is we've seen some of these failures as it goes forward. I'm curious, how do you talk through those conversations as we have those, certain systems go down, you can't watch the movie you want to watch, we won't name names here, but people, that fear of the cloud, how do you, because I feel like we have to have the failures to be able to compensate and ask the next future questions.
We learn by failure.
Yeah.
You learn resiliency by, the good thing about the cloud or anything like running at scale on Amazon is that almost every corner case will be explored. You couldn't have tested for it in advance. And so I think we have to design systems that fail gracefully. Hard failures are forbidden in this world. You have to be able to gracefully degrade.
I love that phrase, fail gracefully.
So I think that's true, but at the same time, while we are overall intolerant when we can't watch a movie we really want to see, the reality is you, in a perfect world, would want your car to never break down, ever. You could drive it a limitless number of miles. You would want your electricity service to never, ever go out, no matter what happens.
And we live through those just fine.
That's right. And they're not going away, at least not with any technology we've seen so far. So to expect that the movie service that you happen to watch will never, ever, ever fail is silly. We have medical devices that fail. I think if we could pick something that we'd all want to have as most important to never fail, I would probably pick the medical devices first. They still have
over
problems. That's right. They still fail. So it's interesting that people are so intolerant of not being able to watch that latest movie, and yet they're tolerant of their car breaking down or their electricity going out during a storm.
And this is why, we're lucky. Humans are resilient that way. And actually, Alistair this morning was talking about organization versus an organism, and that when you talk, and so we talk about the human organisms, we're tremendously resilient. I remember actually during the power outage in New York City a number of years ago, entire city blacked out. What did people do? They immediately, on their own, without any direction, they checked all the elevators in their buildings. They went out onto the street and they helped their neighbors in New York City. One of the most uncooperating city in the world or whatever. But they all responded, and so I think you're right. We are going to live in a world in which there are going to be issues and problems and things like that. But we have to show the resiliency ourselves in how we respond.
So, thinking about these conversations as we talk about now and where the history, where do you rank cloud in terms of its maturity? Are we in the adolescence? Are we in the how mature is cloud and adoption? And again, broad question, but
so we're certainly at just the beginning of this, and it probably won't be called cloud forever.
I agree.
Because I think it'll just disappear and become computing.
It'll be accepted.
Again,
we'll be in a
it'll be
post-cloud
accepted,
world.
just like we're seeing. But I think we already know some things about it. We know it is clearly the fastest way to develop and deploy new applications. When the people who are developing the apps, they don't have to worry about is the infrastructure going to be, or what kind of a machine it's going to run on, or anything else. they get that flexibility. So we're seeing I think there's probably the studies haven't been done yet, but I would say without a doubt that is the preferred way to develop and deploy applications. There's issues, there's latent fears about the cloud, security, or who's going to have access to my data. Can I run my application in the same data center as a competitor of mine? Will I have access to that? One by one, we're knocking those down. And so when I was at Salesforce.com, for example, many years ago, one of the first questions was, security data. How do you protect my data? Now it became much more, can I protect you to be the steward of my data? Will you be around Salesforce because I'm going to now entrust you with this?
Which is interesting. It goes back, though, to an example I used the other day, which was the banking system and your trust in them taking care of your money. Once you go in and give your cash to the bank teller and they take it and say, okay, it's been deposited, you're now fully trusting that your money's there. Where there is, you really don't know. And you're expecting that when you then demand your money out, whether it via ATM or through another teller or something else, that you're actually going to be able to get it out. But you really don't know.
Right.
You don't truly know. They could say, oh, we don't have any record of that, and
that's right.
Good luck.
That's right. So this is the tech talk that we're supposed to be doing, right? So
I was seeing if we had any questions coming in from our users, because we're about at time, and I wanted to see with both of you here, if you had a question you wanted to ask each other, if there's anything you both got to hear the others' keynotes. I know there was some great conversation.
So I get that. So what are the challenges in big data and data gravity? I mean, we seem to be taking a lot of different approaches. Is there something that you think is earlier amongst the stuff we were talking more as physics, or are there some fundamental things that we have to worry about here?
I think where it will get interesting is when we move to real-time systems. And as we move to real-time systems, I think we're going to end up with kind of a compute arms race in the long term of who can get to the information the quickest and who has access to the best resources in real time to take whatever action it is. And that company will be incredibly advantaged. And I think the earliest example that I can come up with of companies fighting this battle are in the financial services, specifically if you look at the stock trades and such. They spend incredibly large sums of money to be advantaged by a single microsecond. They all have the same algorithms. They're constantly trying to come up with an algorithm that can extract more insightful information out of the data of a trade. And then they try and mask their activities so that the others cannot see it. That's the most evolved example I can give. Most businesses will end up evolving to something like that in their own industry. It probably won't be quite that extreme, but it will be something along those lines. And that's where big data is going to take us. It's going to take a while, so I'm not saying in 5 years from now we're all going to be doing this. But 20 years from now?
Speed of light, distance.
That's right.
That data has to travel, or our response. I mean, actually, can you observe something happening at a distance and make an intelligent response around it in time?
That's right. Well, and they had that recently, that breakthrough in fiber where we can actually transmit the data faster through fiber. Well, so what do you think all these financial services companies are going to want to do? They're going to be rerunning fiber because that's a huge advantage, and all of them will have to do it to stay competitive.
Yeah. And one of the ways that even on the networking side where you start advantaging that is that you're, again, making decisions in the network because you don't have time to sort of go back to your data center and make a lot of these decisions. So being able to, particularly in these very time-sensitive applications, you have to be able to have those local feedback loops happening right there on the edge of the network.
We got a viewer question. So, Dave, do you plan to build something that shows how data gravity theory can work? And it's a two-parter. And Lew, application that might have for OpenStack. So it's a 2-for-1.
Interesting. So I intend on putting together what I'll call a very poorly coded, because I do not claim to be a rock star with my code, but I do plan on putting together a reference bit of code to show how this should work, so that hopefully people vastly better at coding and smarter than I can turn it into some very interesting projects and real things. Those are some of my plans in my infinite amounts of spare time that I have right now.
So when you do that, Dave, I can make sure that we can actually express a blueprint in OpenStack and see if we can get others to contribute code along with you. I think one of the things that we find as we're forming these open source communities around these things, and OpenStack is a set of services. It's not designed as a monolithic thing. It's a set of services, and we keep adding more services as we discover the need for them or the possibility of developing them. And so I think that's exactly the kind of thing we'd like to see.
Well, listeners, you heard it here first, so we'll be looking for more from that. And Dave, as a closer, do you have a question for Lew? Anything you want to, well, besides when can you leverage OpenStack for this?
Sure. So I guess my question would be, where do you see the future of networking going based on the fact of all of these pulls around data gravity and such?
Sure. It almost comes back to where we started, is that there's always been this debate that we either want networking to become just really fast and dumb, or do we want it to be more intelligent. And more intelligent to me means we're pushing actually computation and computing ability into the network. And I am firmly on the side that we need more and more intelligence in the network. And that's why we're seeing SDN and everything as programmable. So now you have to be able to actually put programs that are running on your routers and switches or network elements, so you can start to turn it into services. So that means that we've talked about content-aware networking, we've talked about application-aware networking. I think we're going to start to see those things. If we can get the right abstraction, what we need to do that right, you really need to move up a level and start talking about the abstractions that you want implemented. And then it becomes pretty straightforward how you go and build that into the network.
Well, great conversation. Thank you so much, Lew. Thank you, Dave. And we're out of time for this week. So if you like the show, add some knowledge to the data. You can tell people and let the gravity pull you in. So you can tell a friend, leave us a review on iTunes. You can follow us on Twitter at thecloudcast.net or on the web at thecloudcast.net. Thanks for listening, and we'll see you next time.